Okay. Suppose the sequence AN converges to A and the sequence BN converges to B. Prove that the product of AN and BN, the sequence of the product, converges to A times B. Okay. Classic problem. And we'll do this in the most natural and intuitive way. So I will first start off by pointing out that since Bn is convergent, it is bounded by some positive m, and for this proof isn't specific that I choose B. You could do the same thing with A, but you'll see later down the line in the proof, it's not going to matter what we choose. We just have to switch up how we define things if we do either or. But first we'll do since the sequence Bn is convergent, it is bounded by some positive real number m. Okay, and then I'll just unpack definition for converging to A and converging to B. So for every positive epsilon, there exists an n1. Since we have two sequences, we're going to do n1 for AN and n2 for BN. There exists an n2 such that for all n greater than or equal to n1, okay, we have that the distance of AN and A is less than, all right, this is where I'm going to choose epsilon over 2m. And if you chose AN to be the one that was bounded, again, they're both bounded, but whichever one you choose to say is bounded, then you put the bound on the other one. So I put it on A. Okay. And I'm going to do the same thing for B. There exists an n2 such that for all n greater than or equal to n2, we have that Bn minus B is less than epsilon over 2. The epsilon over 2 is coming from, we're going to add them together, and the m is going to cancel out for some bound of B of n, and we're going to put a absolute value A on this guy. Okay, and because we have two conditions, we want both n's to work, so we're going to take the maximum of n1 and n2. So take n to equal the maximum of n1 and n2. Then, for all n greater than or equal to n, okay, we're going to consider what we want, an bn minus ab. This is equal to an bn, and I'm going to put in a zero term, so I'm going to add and subtract the same thing, and you can either take an b or you can take bn a, just some mismatch combination. From the way that I set things up, I'm going to take minus bn a plus bn a, so it adds to 0, minus ab, and from here, what I'm going to do is I'm going to factor. There's a bn and a bn, so I'm going to factor that out, and then over here, there's an a and an a, so I'm going to factor that a out. So this is equal to bn times an minus a, sorry, it's a parenthesis, plus a times bn minus b. So you'll notice this is nice because this b we have a nice bound on. It's our m. This a, which we're eventually going to put an absolute value, we have a nice bound on. And then the insides of the parentheses, we also have nice bounds on. And so I'm going to use triangle inequality to separate these two. And then I'm going to separate the absolute values as well. So we get the absolute value of bn times the absolute value of an minus a plus the absolute value of a times the absolute value of bn minus b. Now, since we know the bounds of all of these, I can say that this is strictly less than, well, this is m times a is epsilon over 2m, so the m's cancel out, we're just left with epsilon over 2, plus absolute value a times, this is epsilon over 2 absolute value a, they cancel out, epsilon over 2 plus epsilon over 2 is equal to just epsilon, which is exactly what we wanted. Thus, we have that the sequence an times bn converges to the product of a and b. That's the proof.